do have some slides, and I'm gonna try to deviate and get into the code as much as possible and demos, but a lot of this requires some context. So we'll do that. Let's start off with Docker promises to help you build, ship, and run your applications. And image pipelines are all about the building and shipping part. Ultimately, we want to get software from our source control system to production quickly. And, we have developers who are all the way on the left side of the process, and, they're working hard and building things. And then we have operators who are running those things. Sometimes they're the same people, oftentimes they're different. In the middle, there can be a bunch of sadness. This guy is on the cover of Docker in Action, but I assure you, I wore my Docker in Action Containers Make It Better shirt today. Hopefully you can see this. So Docker packages software into images for easy handling and running. And in some sense, if you're not familiar with Docker images, that's okay. Docker in Action, the book will teach you all about that if you want to learn about it. But ultimately, you can think of them as essentially a zip file with a bunch of information attached to it that makes it easy to package all your application and its dependencies inside that image, and then run it. And it's designed for automation to be able to move these images around and inspect them and so forth. And we're going to see a bit about that today. Name them properly, attach metadata, etc. Let's go back to that image again. There's a number of jobs to be done when it comes to delivering software. We have to package software and its dependencies. We have to verify the package is good. We have to label, identify it, name it. We have to store the package. Then we have to deploy the right thing. And then ultimately we have to run that with the right configuration for that environment. And sometimes that's not all that easy. Let's dig into image pipelines, because that's what's going to help us take care of all the concerns that we showed on that page. An image pipeline is a way to model that process and solve those concerns that I just talked about, kind of with a process that is designed to satisfy those concerns. We're very much interested in correctness, both in putting the right things into our image and then making sure that image is configured to run properly. What we're going to do is we're going to prepare to build the image by checking out the clean source code and either creating that application right there or retrieving dependencies. And I recommend you put your Docker file, the thing that defines your image and the thing and the process, the code that defines the image's build process, right in the application source. And that way it's under the same version control as the rest of your application. It's really no different. It's just, there are many aspects of what go into a Docker image that are just as important as as many of the bits of application code. So it makes sense to version and change them together, track their changes together. We need to be able to get a clean copy of the source code with our instructions for building the Docker file and our Docker image, and that'll be the preparation stage, along with retrieving application artifacts or perhaps building it. In this example, we're actually going to build our own application artifacts. And then you build the image, and that's done with the Docker file, which again, you can learn a ton about in Docker in Action. And then you can verify that functionality, you can verify that the image was built correctly. So you can do some things to make sure that the right files are in there, that they have right permissions, etc. You can also do things like vulnerability scanning. Once we're pretty sure that it's a good image, we can tag it and then publish that image to a registry for that image to be deployed somewhere. And the goal here is to build confidence that the right application is going to run once you actually deploy it into production. which seems like sort of like obvious and like, oh, that should be easy, but it's actually full of like little gremlins all over the place in practice. And Docker is here to help us with that. There's a few ways to build Docker images, and we're going to talk about like 3 patterns, and we're really going to show this middle one, the build and runtime one. So, each of these patterns are useful and appropriate for different situations. So let's just name them real quick. There's the all-in-one. There's where you separate the image that you build your application with from the image that actually contains the application. Then there's build plus multiple runtimes. So you might create other specializations. So let's look at those real quick. In the all-in-one pattern, the image, what you do is you actually put the source code inside the Docker image that you're going to create, and it has all the dependencies to build your application. You build the application, say you're building a Java application. You actually compile it, the application inside the target image, and like you write the jar out, or like in a Golang program, you would compile that binary inside the image, and like it just lives on the image file system. And it's easy to start with. It's good for proof of concepts, but because you have both build tools and your ultimate application in there, it's got extra stuff. So I'll show you what this all-in-one means. So we have, or actually let me back up and say, like, we have right here a super simple, let me see, I need to switch this around a little bit. I have a super simple web application built in Spring Boot. The application here is totally immaterial, really. But it's a little web service, and if you hit the home page, it responds with "Hello, Docker World." That's not terribly important. We can build this in like 3 different ways. We're going to show the different patterns. So in the all-in-one image, and I put the links to each of these Dockerfiles at the bottom of the slide. These are all on GitHub, so if you want to check them out, you can. So what this is going to do is it's going to start with the Maven 3.6 and Java 11 base image. It's going to do a few things. First, it's going to like kind of set up this project directory. And then it's going to expect that what it's going to do is going to copy all the source code inside the image that it's building. That's what this copy command does. Copies it into the work directory. And then it changes the process that is running the Docker build, changes into the work directory. It runs a Maven build, clean, verify, and then it takes the jar that's built from the work directory, and it copies it to /appjar. And then finally, the entry point. The entry point is a command that is run by Docker when the application starts up. It's the first thing that gets run, and it's going to run Java jar, which is going to run it. So why don't we actually take a look at that now? Pulling up, this is the live book for Docker in action. We're going to run these commands by hand. So let me explain what's going on here. First, we have the Docker command, and it's going to invoke the image subcommand and the build subcommand off of that. And what this is going to do, it says, let's kind of skip to the end here. I'm specifying that we're going to run the all-in-one Docker file, and this dot means send the files from this directory into the build context. And then when that image builds successfully, go ahead and tag it with this all-in-one Docker in action, chapter 10, all in one tag. So let's go ahead and run that. Let's see, it's going to compile. Hopefully this doesn't take too long. Let's see. It only took a few seconds previously. It's not great to, not a whole lot of fun to look at. Let me go back to what's going on here. So because the Docker file, the from image, the image that we're building from, is the Maven JDK 11 image, and we're building our application inside here, and then we just run it directly from within this image. And so we're pulling in Maven 3.6, like the full JDK, etc. So this is what I call an all-in-one image or a kitchen sink image, and like it's great. You know, you can see here that we built the image and tagged it successfully. It's like, you know, we can do all kinds of things here. We can run that. Let's just do that now. Run rm it. Okay. Let's see. So we see Spring starting up. That's nice. Oh, you know what? I didn't run it with any ports exposed. Let's go back and add that. Let's see, 8080, 8080. Okay, so let's see. Great, so it worked. Awesome. Some things that maybe we don't like about that are if we list the image repository, if we like show the information about it, like show what images are in our Docker in Action chapter 10 repository, we'll see that, okay, here it is. This is the thing that we just created a couple minutes ago, and it's 709 megabytes. Like, okay, great. Proof of concept, awesome. But you know, there's probably extra tools in there. Like we have this like super duper simple application. So maybe we can do better. All right. So the next thing we can do is we can use what we call the build plus runtime pattern, where you build and run your application with separate images. And this is nice because we like having all of our build tools inside a build image. That's great. I mean, like I don't want to have I don't have JDK 11 or Maven 3.6 installed locally on my machine, and if I did, I don't know, would Oracle like come yell at me? I don't know. Building and running your application are separate concerns. And like while the build of this application is relatively simple, I've worked in plenty of places where the build environment required like a 12-page wiki, at least until we automated it with Docker. Let's try this pattern where we separate out our build image, or the image that we're building with, and like that's a distinct thing from the image that we run with. Like there's no inheritance going on there. So we're gonna build application with one image, and then we'll package the application artifact into a runtime image. And this makes it so that we can deploy only the runtime, which is going to be a little slimmer and more secure. So first off, let's take a look at the runtime image. Okay, so now this Docker file is super simple, and maybe it might be better for me to go ahead and pull this up over here, my IDE side by side. It's right here. Can't type. Okay, split vertically. Okay, so here's what we had. Here's what we have now. So these are like literally the same lines at the end, or very much so. Except now there's kind of this assumption that we're getting, our preparation step is getting or retrieving the artifacts from somewhere else. So how did that happen? Or how do we do that? So again, let's see. So I'm going to copy this. And the reason I'm copying this like right out of the Manning live book is just try to kind of show you that like you can reproduce this whole thing yourself. There's not really much magic going on here. Okay. All right, so let's explain this command before I run it. So what I'm going to do is I'm going to use that Maven 3.6 JDK11 image, and I'm only going to run the command that I needed to run. I needed to run Maven clean verify. If you see in the original all-in-one image, that's all I was running in here. So actually, let me move this around so we can see both at the same time. In my original all-in-one Docker file, I had Maven clean verify, and that was the only thing that was going on. So I can go ahead and just, I can run that directly as a container. And then there's some other things going on here where I have mapped my current directory. I've used what's called a bind mount, and I've taken a directory on the host, the present working directory, which is interpolated by this shell. So let me hit Control C, echo pwd. Okay, so on this is the actual directory on my Mac that I'm working within. I guess have insensitive or non-sensitive directory names, but what it's going to do is that's going to be expanded, and it's going to mount Docker for Mac is going to mount that directory into this container when it runs it in /project. So you can kind of think of this command that I'm about to run. Let's go back over here. You can kind of think of this command that I'm about to run as like just a transformation of that Docker file, like back into, I'm going to give access to the container, give the host directory, put that inside the container at /project, run commands from /project. That's what this W means. This is the working directory. We're going to use the Maven 3.6 image that's equivalent to the from, and then we're going to run Maven clean verify, which are command arguments. So, all right, let's do that. Enough talking. This might also take a minute. Let's move back here. So we get a bunch of scrolling. And so what we're going to do is, okay, so we're kind of using that build image, that Maven image as the build image, and we're running it as a container, and it's going to produce an artifact. So now there's a file here in my target, in the target directory on my local machine called chapter 10 0.1.0 jar. And let's see, target checker. All right. So that was built just moments ago. Now we have an artifact. So this is the equivalent. We've essentially prepared to build our image. We've retrieved or created the application artifacts that need to go into our image. And now we can do the simple thing. We're going to build our image, the simple runtime image. Okay, so now we can again run rm it. Let's do 81, so you know I'm not. So we know that it's a different server. Let's see. It should work. Okay, see it starting up again. Change this to be 8081. Hooray. Okay. All right. So now image ls. Let's see what's going on here. Okay, so the simple runtime image, which is only 417 megabytes, which I know some of you may laugh, but go ahead, I guess. It's about 300 megabytes smaller. And why is that? Well, it's because two reasons. One, it doesn't have Maven inside, which has a bunch of stuff. It doesn't have the portions of the internet that were downloaded during the build process. And it's also using the slim JDK instead of the full JDK because the application only needs the slim stuff. So it doesn't need like JavaFX or like whatever else is in the full JDK now. The application still works the same. So that's cool. Now, the last pattern is that you can, once you've got your image separated out, your application runtime image separated out, you might say like, well, there are some extra tools I need from time to time, like maybe a profiling tool or something that performs administrative jobs that needs all the same application libraries. So think of like a database migration or a data analysis or fix-up job where you want to use, let's say, all of the same code that reads and writes data from the database, but you don't want to bake all those tools inside the regular application image. So what you can do is separate out those images, the building of those images, into kind of separate targets, and we're going to show that in. Let's show that now, actually. So I'm going to close. Does that work? Opposite groups. Okay, so this is a bit more sophisticated. And this uses build targets, and you can within a Dockerfile you can name every time you say from, you create a build stage, and you can have multiple stages of builds and produce multiple images from a single Dockerfile. What this is doing is this is saying like, look, let's start this build stage, and we're going to name this app image. And then here's another from. So this starts a new stage. So this is like extending. You can think of it as extending the app image build stage, and we're going to add some other tools. So like we could copy something else in here. This last statement is here to ensure that it creates another stage called default, and it just it's just kind of like an alias here. Like default isn't a special term that like Docker knows about, but what it's doing is the last build stage that's defined in your Dockerfile is the one that is run by default. But let's go look and see. Okay, this is the hierarchy. This is like what the image hierarchy will actually look like. So if you noticed, okay, we started again from the JDK 11 Slim, and we're going to build app image. And then, when we can go ahead and tag as we want, like it's going to tag that app image. And then the app image debug is actually built from that original app image. So this is just kind of a visualization of the different images and layers and so forth. Let's build that now. We won't spend too much more time on this. All right. You know what I want to do is I want to build. I just want to build the multi-stage runtime to show you what happens if you don't name it, specify a stage. Okay, so see the key here is that like I didn't specify a stage to build explicitly. And so because that from app image as default is the last stage defined in the Docker file, that's the one it built. So there's also a target. See, that's why I was messing up a little bit at the beginning. I called it a target instead of a stage. Names matter, I guess. So we can define the stage that we want to build directly. Let's do that now. Stage app image. Oops, I did it again. All right, cool. So because we'd already, we just basically built all that, it was able to actually build entirely from cache. But we can build the debug version quite easily by specifying that one. And turns out, let's go ahead and add a command just to make it do something. Run. Yes. Run. Just copy a file. Okay, so, starting from here, it said, okay, everything, I'm kind of surprised it's not showing as cached, but that's fine. The key here is that, it's going to build, it's starting from the app image, it runs our copy and sets the entry point and creates this other thing. And if we say Docker image ls, then, let's see, I didn't tag it, did I? This command is getting kind of long. It's feeling like I should be automating this. Let's see. Let's just call it app image debug. All right, so that was all cached. All right, so now it's here.